First in, first out. If you're selling IBM stock, you have to find the oldest stock and sell that first. And so I gave this as a programming assignment to make this stock tracker application. And okay, it sounds pretty easy, it's easy to describe, but many students thought, okay, well, the way to do this would be with a queue. And then if you're going to sell IBM, you start at the front of the queue and keep going till you find an IBM and then you sell that. The problem is yanking something out of the middle of a queue, that doesn't work very well. So students had fits with this assignment. So you know if you have a queue which keeps track of the age, that works quite well. So you've got the head of your queue here, and you've got, I don't know, IBM and 100 shares, and then you've got Illumina, 50 shares, and I don't know, eBay, 100 shares, and then IBM, 40 shares. And so the prices on these all vary. So if you want to sell 120 shares of IBM stock, you take these 120 of these. But yanking something out of the middle of a queue doesn't work well. So the students had fits with this, and I had kind of a revolt on my hands. And they were complaining bitterly because they were doing all kinds of nested if blocks and trying to go through, and get 100 of this one and 10 of this one, and there's no limits. If I bought 10 shares 50 times and you needed 100 shares to sell, then you have to find 10 transactions. So the students were going wild with this and going crazy, and we had a mini rebellion. It's not fair. How can you expect us to do this? It's too hard. You get the picture. All right, well, that wasn't the way to do this assignment. It's the first simplest way you might think of, but it's still not the right way to do it. So I went through and I explained to the students what they needed to do. They turned in their assignments and everybody's happy. And we have essentially robots. If I say do this, 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 and this, and don't think, just write code, then we have robots. And what's the point? Nobody's going to pay you money. People are going to pay you because you know how to solve problems. So after that, I thought, you know what? I'm going to talk to a class. So I waited 4 or 5 years, and I said, I'm going to present this problem to you and show you how to go through and find the solution. So I did that. I spent an entire hour talking about how to find the solution to this problem and the steps you should go through to figure out how to do it. And I noticed that no one is paying attention. They've all drifted off. They're updating Facebook, they're texting, they're doing anything and everything but paying any attention to what I'm telling them. And I asked one of the students I knew really well, after class, I said, what's going on? It seemed like nobody was paying attention. And he said, well, Mr. Riggins, what you were showing us is so obvious and so easy. I mean, how else could you do it? And this was really interesting to me, this problem that was so obvious and so easy. When you look at the solution, when given the problem, but not a solution, all of a sudden I've got a riot on my hands. And how could it both be so simple, so obvious, so easy, and impossibly difficult and not fair? How can it be those two things, that same problem? How can that be?
Well, if you don't have any experience on what you're doing, it's going to be difficult. But if you're given the answer, you're just going to think, oh, okay.
Yeah, they look at it and they go, yes, of course, how else could you do it? Right? So this is wrong. How would you do it? How would you do this? What data structures would you use to solve this problem? Yes?
Hash table.
No. Hash tables don't keep things in order.
Linked list.
Well, you're missing the point here. A queue is the right thing. but not that. Do we need a priority queue? No, they don't have priorities. There's no priority here. What do I need? I need an array or a vector of queues. So this is the IBM queue. And in the IBM queue, I have 140. And then I have an eBay or an Illumina queue, and I have 50 in it. And I have an eBay, and it's got 100 in it. So when I buy Illumina, it goes on the tail end. When I sell Illumina, it comes off the front. And how easy is that? You don't have to yank something out of the middle. You put it in the back, take from the front. Is this simple?
Yes.
No one suggested this when I asked you the question. No one. So what's the point here?
We suck.
Is that so hard? Is it? Then why didn't you think of it?
We had time.
Huh?
Needed an adult.
I don't know if there is enough time.
I think that we were overcomplicated.
Well, this is the issue that I want to bring up to you guys, because as a teacher, it's something I tangle with all of the time. I give you a problem and ask you to solve it. Now, for some of you, the problem is challenging and fun and can't wait to get into it. And you go and work it and you do a pretty good solution and all as well. But that's maybe 10%. And many other students go down the wrong path, find a way to make it work, hack at it till it does. The code is so fragile, if you have to change anything, heaven help you. But at least they got it done. Other students become inert substances. Or they get on a Google search and see if someone else already solved that problem. But nobody's going to pay you money to Google search. Trust me, no one's going to pay you for that skill. You need to be able to think of a problem and think of the way to solve it best. So, you know, sometimes students become popular, you get to review everything. You go out to dinner, you don't like your pasta, you flame them on Yelp or whatever. Oh, it's the worst meal ever. You know, everybody's a critic these days. Well, we're no exceptions to that rule. Everyone's a critic. Well, one of the criticisms I often hear is he gives away too much code. He's too generous with code. And that's okay, I'll take the criticism. I think it's okay if there's a learning process there, and I would far rather have a student leave my, say, 530 class saying, gosh, that was such an easy class. Riggins isn't as tough as you guys say it is. That was pretty easy. I'd rather have you walk away saying that than saying, God, that class killed me. I couldn't do any of it. I'm so discouraged. I don't even know why I'm majoring in computer science. I can't do it, right? Well, the thing is, when you're looking for a solution and you don't see it right away, you don't know how far away it is. It could be close, it could be a long ways away. But work the problem. If you sit down and think about what's possible and work the problem, this will help you. So I want to talk about my suggestion for dealing with this parsing a line. So what I want to talk about is limited to the problem of dealing with comments and quotes. So you have a line of code here, and you've got something like 2 x, y, z, x, quote, y, quote, x, star, a, comment, star, and other stuff. So you have to parse this into tokens. So token 1 is x, y, z. Token 2 is x, comma, or comment, y, x. That's one token. And then you have a comment. Everybody agree? Look right? So how to approach it? All right, well, let's just look first at this token. That's one token. Okay, dealing with the quote marks is difficult. Some of you were saying, well, if it has a quote in first position, okay. But you have this one, and there's a quote in it, but it's not in first position. You have to handle all those cases. So you start thinking of cases, and you have if blocks, and if else, if else, if else. So let me suggest a strategy to you here. Suppose that everything in the quotes was removed and replaced with a token. So instead of I put a star in there.
Of course not.
Or if not a star, placeholder. Let's say capital P for placeholder. Similarly here, so this string becomes P, X, X, P, X, and then your comment. Can you tokenize that? There's no quotes. Can you tokenize it? Is it easy? I mean, if you remove the quotes, is it easy? Then why not let's do that? Now you can parse it with this much code. All right, so step one, is there a comment? Does it matter where the comment starts? A bunch of you were looking for comments in line 0 or column 0, first position. If line 0 equals the star character. Anybody have that code in their project? Why? Why? Oh my gosh. So, okay, a suggestion. If you find a comment, yank it out. Use the substring function, yank this out, and store it immediately. Now, this is your string and there's no comments in it. Does that make sense? You know it's going in this data structure. It's going at index 3 or in the comment portion of your struct. So look and see if there's a comment. If there is, yank it out. Okay, and store it. You haven't even started parsing. You look for a comment first. Does it matter where the position is? No. Do I need to know if it was in first position? No, it's irrelevant. You don't need to check and see if it's in first position. The problem with looking for specific cases is you probably will miss some. You will probably miss some. And then your code crashes and burns because you missed a case. But if you don't look for cases, then you can't miss them. If there's a comment, remove it, store it, move on. So you actually modify the line and remove the comment. How hard is that? There's a substring function. It takes 2 arguments. The first is where to start. The second argument is how many characters to take, and if you don't supply a second argument, it goes to the end of the string. So you do a search first. You do find. That returns the index of where the star is. Then you do a substring function and take it off, remove it from the line, and then process the line. You with me? Is everybody with me? Okay. Does this sound like something like totally radical or something you might have thought of? Did anybody think of this? Did anybody do this? Anybody?
Zoom substring function?
We talked about this,
We
didn't
talked we talked about it.
Yeah, okay, so where'd the idea come from?
I asked you actually.
Okay. So nobody in the class independently came up with the idea, just yank the comment out and move on. Okay. You did? Good. It was a good idea, I liked it. Okay, the next thing. If you're gonna replace this with a symbol, what could you possibly replace it with? Are there any illegal characters here?
No.
Not really, so what are you gonna use? So one of the problems, of course, students will think, well, okay, let's play the probabilities here. It's not likely to be a vertical bar, so I can use a vertical bar. And then you think, oh wait, there might be. So I'll use two vertical bars. Okay, it's less likely that this will occur anywhere. Well, let's do three. It's extremely unlikely. But the problem is, you're betting. Is it possible that this could be in one of the tokens? Yes. Oh my goodness. So the P obviously isn't going to work because you're going to have a problem with every P. You're going to think there's something to insert there. So the idea is you yank this out, put this in its place, and then at the very end, after you've tokenized everything, you put this back. Easy. So the idea then is you don't even look at what's inside there. You don't even look at it. You don't care if there's spaces or anything else. Okay, so to do that, you need a placeholder. What can we use? We need something that will not ever occur in that field. A star, because you took them out. So you're guaranteed there are no stars. Yes?
So when you're pulling out the comment, you're just looking for the first occurrence of a star, right?
Yes?
Once you run into trouble is if there's a star in the quotes.
If there's a star inside the quotes, yes, you would.
So now we
You would.
So if we're just pulling out the comment, the first thing we do is
Right. So you're going to have this issue. Yes, absolutely. If there's stars in the quotes, you're going to have the issue. So you're going to have to look and see where the comment is first before you yank this out. So if it's inside the quotes, you will have to check it. Absolutely. All right. So I have posted this online for you guys to look at. The idea is just this: replace the quoted matter with the star, and then you put it back at the end. And this makes for very easy. So the amount of code is very short. It is certainly the case that if you have the star inside quotes, you have to look at that. You will have to take that out first. But anyway, this is the amount of code it takes to do it. It's one page and this much on the next one. So that was a suggestion for you guys, and you can look at that on the class website. Questions? All right. I'm going to talk now about the test. So, when's the test?
Next week.
Next Wednesday. Okay, we've got 1 week. We've got 1 week. So, let's talk about what's going to be on the test. This is last semester's, so it won't be this same test in case you have a buddy that took this test in the spring. It won't be the same, though it will be similar. So I have true-false questions. There's a bunch of these. I ask true-false questions for one reason. It's easier to recognize than remember. You can recognize something and say, yeah, that's true. No, that's not true. But if I ask you to give me the term, it would be more difficult. So let's run through some of these. So you guys tell me if it's true or it's false. So I'm not going to post this, but if you can take notes as you're going, that's fine. Okay, so true or false, assembly language code is machine independent. Well, I heard true and I heard false, but yeah, it's 50-50. What does machine independent mean? Okay, so this is false. Assembly language code runs on exactly one machine. It's completely dependent on the architecture. All right. Java is machine independent. It will run on any machine. Assembly is the exact opposite of that. Okay. Assemblers are much less complex than compilers. True or false? Assemblers, this is a statement and it's either true or it's false. Assemblers are much less complex than compilers. True. It's true. Okay, a tricky one, listen carefully. I like it, so it may occur on your test. Encoding memory references by using displacements rather than the actual address in memory in the machine instruction makes it easier to relocate the program. Using displacements instead of actual addresses makes relocation easier. True. Absolutely true.
Yeah.
Yes, it sounds confusing, doesn't it? So you have two ways to encode a memory reference. You're going to ask the CPU, ask the machine to read a memory reference, i.e. alpha. Go to alpha and read the word contained in memory at location alpha. So you have to encode alpha. So alpha has an address and you can encode that address. Then it says go to this address and read the memory. The problem is, if you're doing relocation, that memory location is no longer valid. If you relocate the program to some other place in memory, that hard-coded address is invalid. However, in an assembly language program, all statements, all labels have a positional relationship. I.e., suppose we're talking Java. If I want to set y, can I use x? I want to say y is 2. Can I use x to do it? Well, what a funny notion. No, you can't do it. How would you do it? That's impossible. Should I use y to set x to 4? I want both of them to be 4. Can I use y to do it? Yes. If they're words, yes. This address is 3 more than this one. So y minus 3 is the same as x. You with me? So all labels have this positional relationship. So very often, in the bad old days, a programmer would do something like this. Data. And that would be the only label for a whole storage allocation. Reserve byte 100. Reserve word 100. Okay, what's the address of this first word? Can you find it? Yeah, you can. So there's no label for this. This is data, data plus 3, data plus 6, data plus 106. Decimal. You Do you see the idea? So everything has a positional representation or relationship. All right, so if I need to encode data, I could hard code the actual address, but I'll have to change that when the program loads into memory depending on where it ends up. But instead of that, I can mark a distance from some known fixed location in the program forward to data. So suppose I use base. Then it would be forward from base if I use data, or the program counter, but it's essentially go in bytes forward from some fixed and known location. And that works no matter where the program loads in memory. You with me? So that makes it easier to encode because you don't need to change it. You don't need to change it. It's also typically shorter. Okay, what else do we have here? Location counter is a variable used during the assembly process. True or false? The location counter refers to a variable that's used during the assembly process. That's true. The program counter refers to a variable that's used during runtime. Is the program counter used during assembly time or during runtime? Runtime, it doesn't exist at assembly time. A forward reference refers to a label in an operand field that has not yet been defined. Forward reference refers to a label in an operand field that has not yet been defined. So as an example of this would be operand field, not the operator, operand field. And is it forward reference? Has it been encountered yet? When you're doing this line, have you found data? No. So it is a forward reference. It has not yet been encountered. Assembler, somebody had a question? Okay. Assembler directives do not generate any object code. False. False. A tricky question, isn't it? Some do, some don't. Does this generate object code? Sure it does. What goes in the object code? That becomes part of your executable. Yes. No. No. So not every assembler directive generates object code, but some do. Where you're declaring constants, that does. All right. Let's see here. If an SICXE operand has a plus in front of it, it means it must be encoded using format number 4. If an SICXE operand has a plus in front of it, that means that the instruction must be encoded using format 4. You should know all 4 formats. 0 you don't care about, but the 4 formats I'm going to ask you those. So is that true or false? False. That is false. Why? It's a tricky question, I know. A plus in front of the operand. Is that where it goes? Now, it's not a trick question if I tell you about it, is it? I don't think so. There's a difference between operator and operand. Okay. So do read these questions. The @ symbol may be placed in front of a memory reference operand, in which case this means that the memory location contains an address to be dereferenced. True? True. Yes. The pound sign can never appear in an operand field. False. In assembly language, the pound sign in front of a label means the address of that label. Yes, it's exactly what it means. All right. So, during encoding, if you set N to 1 and I to 1, remember we have the bits NIXBPE, you set N equals 1 and I equals 1. That means the addressing mode is both indirect and immediate. False, it's neither. A format 4 instruction may have a 20-bit immediate value. Yes?
I'm falling way behind it. You said these are going to be on.
Exactly. No, I'm not posting these questions. I'm just giving you a sense of what to study. Sometimes students tell me I haven't the slightest idea what's going to be on the test. All right, so I'm telling you. So these are details about the assembly language for this architecture and how they would be assembled. So, no, I'm not going to post this because if I post this, I can't reuse any of these questions. If I don't post it, I may pull some of them. So, if you can't write fast enough, I don't know what to tell you. I'm trying to tell you what's on the test, not supply you with questions that you can memorize and then come and take the test. I'm not suggesting you would do that. But basically, I'm giving you information that may, in fact, be on the test, and so I'm going to tell you, but that doesn't mean I'm going to post it online. That would make it too easy. Format 1. A Format 1 opcode can never have an operand. True. It's Format 1, it's an 8-bit opcode, and that's it. There is no operand.
I think we get the question.
A Format 1 opcode can never have an operand.
I think it's the one before it.
Huh?
I think we skipped the one before it, where the format for immediate.
No, the Format 4 instruction may have a 20-bit immediate value. Sure. Yes. All right. The maximum amount of memory supported by SICXE is 1 megabyte. One megabyte. Is that the max memory? So how do you know? Okay, how big is the address field? How big are addresses? 20 bits. What's 2 to the 20th? A megabyte. So true. That's it. Yes. If the starting address for an SICXE program is 0, the program cannot be relocated. False. Oh, this is a good one. The indirect addressing mode, n equals 1, cannot be used with an immediate value.
Do you repeat that?
Yes, the indirect addressing mode, flag n equals 1, cannot be used with an immediate value. Well, what would this look like? What would it would mean n and I, yes. And If you have N and I, it means neither one, because you can't have both. It's impossible. That's like this. No, this doesn't fly, right? So one of the other things I'm going to ask you to know as we get there, which bit patterns are valid for the flags? Okay, so I'm not going to give you the solution to this. I want you to think about it. I will ask you one of these kinds of problems where it's an open-ended question and you basically want to give me your answer and justify it. A developer is writing an assembler for the SIC-XE architecture. So he's not writing an assembly language program, he's writing the assembly. He finds the requirement to put a plus in front of all format 4 instructions to be unacceptable and decides that his assembler will get rid of the plus requirement. Well, what's the issue here? As you're going down assigning addresses to each line of code, how do you know whether you need format 3 or format 4? Format 4 you need if it's too far away. If the forward reference is too far away. So for instance, we might have this. Well, this is 4,000 bytes. All right, the furthest you can go forward with PC relative to mode is 2047. So 4,000 is out of the question. All right, so you have LDA, and suppose down here I have alpha. Word 20. Okay. So the assembler is here. You're coming along doing instructions and you have LDA and alpha. Without knowing whether or not format 3 or format 4 will work, how do you get the next address? Suppose this is address 2. What's the next one? Well, it's either 1.5 or 1.6. So this architecture, it says you have to put a plus in front of the LDA if it's going to be format 4. But you're telling the programmer that's writing code that he has to calculate displacements to see how far away alpha is. Well, that's ridiculous. When you're writing code, you don't worry about things like that. But here, you need to know how much space that instruction is going to take. Hence, with this design that Dr. Beck came up with, he's saying you have to put a plus in front of it if you need format 4. So the problem then is this. You want to write an assembler that doesn't have this requirement. The assembler has to determine the next address without knowing for sure whether it's format 3 or format 4. Does everybody understand the issue? We good? Okay. So here's the scheme. The assembler will simply insert a base directive every 4,000 bytes and use that as an anchor point for calculating base displacements. Now base only goes forward. And the maximum is 4096, or 4095 rather. So 4,000 is in range. So the assembler inserts a byte, or a base directive every 4,000 bytes and uses that as an anchor for calculating base displacements. So he will always have a base anchor point at least every 4,000 bytes, which is within the allowed base range. Thus, all format 3 instructions that contain forward references will be encoded using base relative mode. Will this strategy work or will it not? Does everybody understand? Okay. Think about it. Now then, there is an instruction or a question here where I'm giving you bit patterns. So I'll just pick one at random and write it down so you can see what I'm talking about. The question looks like this: valid. I will do this on your test. Invalid. It's a good question. I like N, I, X, B, D, E. So I'm picking one. Could there be such an instruction, or is it nonsense?
Yes. That's fair.
Well, what about this? Is that legal?
Neither base nor program.
Neither base nor PC relative, and not extended. Huh. Will that work? Yes, it's valid. It's an immediate value. I.e. this. Is it immediate? Yes. Is it indirect? No. Is there an X? No, there's no X. Base relative? How are you going to encode that with base or PC? No. Is it format 4? No. This is valid. So I gave you guys a sheet with all the validates. You got that at the beginning of the semester. All right, so I have, I don't know, a dozen or so questions like that. Not a dozen. Then one should strike terror into the hearts of every student, I think. There are one or more errors in the following C++ code. Explain what is wrong with it and what it should be. Your answer should be precise, detailed, and concrete. Points will be deducted for assertions that incorrectly identify something as an error. You say it's an error, nothing's wrong with it, that costs you 2. No shotgun approach. So there are precisely X errors in the code, and I want you to list X errors and what they should be. You with me? Yes.
So if you get it wrong, you actually lose points for the entire test.
Well, let's say that there are 10 things wrong. You identified 11 things wrong. I'm going to take points off. You got all 10 that are wrong, but you got flagged something as wrong that's actually correct. Yes.
What if you were just thought it was wrong and you marked one wrong, so you have 10 answers and there were 10 wrong, and you mixed one up? Do you still lose points, or?
Well, the point is, if you don't identify something as an error, I'm going to remove points. If you do identify something as an error that's not wrong, I'm going to remove points.
So if we leave it blank.
So if you leave it blank, you lose all the points. If you give me 10 things wrong and then 10 things that aren't wrong, but you think there are, you probably lose all the points. When you lose points if you fail to identify what's wrong, and you also lose points if you identify something incorrectly. So the goal here, in case it's not obvious, is some of you worked really, really hard writing C++ code, and some of you did nothing. And we're going to find out who that was. We're going to separate the sheep from the goats, so to speak. Yes?
So it's theoretically possible for somebody to identify 10 wrong things and get minus 20 points for the question?
Well, I'm not going to give you a minus score on it. I mean, if it's worth, if it was on this test, it was worth 50 points. So you could get minus 50 here, even if you identified all of the things that are wrong. Now this is preposterous because you have to identify everything that's right as wrong as well. So, you know, this doesn't happen. What does happen, here's the reasoning behind this. Students are looking at something and they don't remember, is it right or is it wrong? Okay, well, it isn't the shotgun approach. Just flag everything you can think of and call it all wrong and hope you got all of the wrong ones, and he'll just ignore the things you flagged as wrong that aren't really wrong. Doesn't work that way. So I'm going to grade everything you write down, and if assertions are incorrect, that costs points. Yes?
You're just going to randomly hide a parenthesis.
Randomly hide a parenthesis.
An extra parenthesis or an
That's an
extra closing
idea.
Yeah.
That's,
Maybe you can forget that.
all right. Well, here's one.
It's gonna be close.
Of course they're gonna be points. Yes. But, all right, this is right off of the spring test. Now, string, pair. Legal, not legal. So you're declaring a map of type M, where you know the name of the variable is M, and the angle brackets are what it takes.
What's the second point? Exact point?
Pair. Okay. Yeah.
So it's
It's legal, it's perfect, nothing wrong. About half the class told me that was wrong. So I got my wrist hand. Now there was a reason, right? Their assignment was different. So don't think that I would give you this. The reason I wrote this on the board is this isn't going to be on your test. They were doing opcode. So the form of this map is they have something like add, or let's use LDA because I know what it is. LDA. So there's the key, and you have to look up two things. When you look this up, you need to know the opcode and the size, format 3. So there are two values that go with it, hence the pair. All right, so we talked about this in class last spring because they're writing an opcode lookup table to start their assembly. Therefore, this question is something they saw, and this code is something they saw during lecture on the morning class. So I don't want you to think I'm going to come up with something just as crazy as I can to throw at you so that I can give you all bad grades. That's not the goal. Okay. So you will have code. Yes, Kenny.
I don't suppose you're going to tell us how many errors there are?
No, I wouldn't think of telling you how many. Yes?
So, what's the best way to study for this test? Just
Well,
read the book?
okay. The C++ stuff, I don't know what to tell you, but you should look very carefully at the code your team wrote and make sure you understand every bit of it. And if you don't, call the guy that wrote it and ask him. Hopefully, you didn't write it if you don't understand it. Yes, the C++, I'm going to focus on what you used for this assignment, not can I find something weird off the wall to trick you. That's not what I want. The goal is to see who did it, did the work, and who didn't. And by asking very straightforward questions, i.e. I wrote that on the board in class and showed them this is probably the easiest way to look up two things. You have a key, LDA, and you have two values, that it's format 3.4, and the opcode is 0.0. You got to look up two things. So rather than having two maps and looking it up twice, you can just store a pair, do it this way. So they saw this because it was relevant. This year you have a different assignment, so the questions are going to be different for that reason. So I don't want you to be terrified here that I'm going to nuke you. I'm trying to guide your study. Read through that Beck chapter on assemblers with a fine-tooth comb and make sure you know the architecture details, so chapters 1 and 2. Now there is in the end of chapter 2 a whole bunch of discussions about different architectures. Many of them archaic, no longer used, who cares? So I don't want you going through memorizing the details of Pentium Pro architecture because it's in the back of that chapter. Don't bother with any of that. None of it. Just this made-up fake architecture that's detailed and used as examples in this book. You've read chapter 2, yes? I mean, it was assigned, you looked at it. So it's like a discussion of Spark, a discussion of MIFs, maybe a discussion of Pentium Pro, right? Those architecture details we don't care about. There are a lot of details about assembler features that might be used. And we're not gonna focus on that because you're not doing an assembly in this class. But the architecture in the book and the basic functioning of assemblers, you should know that quality. What happens in pass 2? What happens in pass 1? That kind of thing. All right, the next question. Write down the 4 formats. So I have, here's format 1. That's the base SIC. Now write down formats 1, 2, 3, 4. This is format 0. Write down the 4 formats using this kind of notation, which is 0, 1, 2. So let's do 2. So you have an 8-bit opcode, right? And then register 1, register 2. Format 1 is the 8-bit opcode. Format 3, you should know that. 6-bit opcode, 6-bit flags, 12-bit displacement. They're in the book. Look at them. Make sure you can reproduce it. The last question. Fill in the addresses in machine code. Here's some assembly language instructions. Assemble it. Generate the machine code. And then there's an attachment here, which comes from the back of your book. All the opcodes and sizes. So let's do one of these, actually. Let's do a couple of lines. You see what I need you to do. Address, machine code, and then here's the source. Okay, so we have PROG start 5,000. So that's hexadecimal. What's the address of that? 0, 0. Next line. What's the address of this line? What's the machine code? Nothing. Right, base is an assembly group. L, E, B, pound sign B. So, of course, now what's the address of the LDB? That's the starting address. The first executable instruction gets that address. All right, now we don't know the address of beta. So you go through the first pass and generate all of the addresses. That's what you would do. So this is blank. I have no idea what the address of beta is. So I'm going to make something up. I'm going to say 102 is the address of beta. So that is the address of beta. I just made it up. So can we encode LDB beta? Now we need the machine code. So you will look on your little cheat sheet. LDB is 68. That's the opcode. So the opcode right over here is 68. Remember, the opcode is 6 bits. Then you have the flags, N, I, X, B, E, E. N, I, X, B, D, E. All right. Is it either indirect or immediate? Yes, which is it? So 0, 1. Is the X bit set? No. Now, are we going to use base or PC relative? You can't use base. You know why? Because it's not set yet. You can't use it till it's set. Okay. Base, no. PC, yes. E, no. No plus in front, so that E has to be 0. Now you need the displacement. So that is the destination minus PC, or destination minus source, plus 3. All right. The destination is beta. That's where we're wanting to go and read something, 102. Minus source plus 3. Now, why plus 3? Why the source here is 5,000. Why did I put 5,003? Yes, the program counter is a runtime thing. It moved. You had to read this instruction before you could execute it. Once you read that instruction, you moved the program counter to the next line. So the program counter, oops, 2 to 0, is here. Okay, we do our subtraction. I hope you can subtract. 2 minus 3, no. What do I want to put here? 15, 16. So 18 minus 3, F. 15 minus 0. Wow, how about that? Okay, so now we have 6, 9, 2, 6, 9, 2. And then so that says go forward from where you're at right now, which is 5,003. Go forward 255 bytes and read what's in memory there. Got that? You with me? Yes.
So when we like just guessed on the address of beta, isn't there a way we can do like that first pass and then get?
That's what you have to do, but I'm not going to write this all on the board because it'll take an hour. I mean, it won't take you during the test, at least I hope not. But to sit down and go through and explain everything as we go, it seems to take a long time in class. Last time we did this, it was in Monday, and I had like 6 instructions, and it took 40 minutes to get through 6 instructions, which is great because you're asking questions and learning how this works, but it's very slow. So on the test, I mean, let me see how many lines are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. 2 of them take no action, they're blank. So that's 9 lines you have to write. So it won't be exactly this, but this is the idea. You see what to do, yes? Okay, that's your test. That's your test. So, some of you guys came in a little bit later. We rearranged teams. Team Alabama, California, Colorado, and Kansas no longer exist. If you're in one of those teams and you do not know where you're going to, please come and ask me. Come and ask me. So that's Alabama, California, Colorado, and Kansas. Your teams are disbanded. This is to make the teams larger. All right. So, over the weekend, study this. Hit me with questions on Monday. We will continue. I will give you your next assignment on Monday, and we will continue and finish up the assembler stuff. And then Wednesday is the test. Yes.
So you're gonna have office hours on Friday?
Yes, I will have normal office hours this week and next week. Yes.
So for a question like that, would you do what we did with the last one where it wasn't, so we did the LTD to go through everything, and then we ended up needing a plus at the beginning?
Didn't do it Monday.
Last time we went through.
Hang on.